Hello there. Imagine an alternator supplies power to the sump motor. Since the sump motor is an inductive load, it will offer a lagging power factor to the alternator. In our video, Armature reaction in alternator, we have learned that if the connected load is inductive, the armature reaction will reduce the magnitude of the main field flux, which will cause the reduction in induced EMF. Are you curious to know why it happens? This video will help you to explain how the inductive load reduces the magnitude of the main field flux. Interpret the phasor diagram that represents the relationship between field and armature quantities under lagging power factor load. First, we will take main field flux phi f as a reference vector. As you know, the length of this line represents the magnitude of the main field flux, and the arrowhead represents the direction. Since the rotor is rotating, this main field flux induces the EMF EPH in the armature conductor. Here, the induced EMF will lag the main field flux by 90 degrees. Do you know why the induced EMF lags the main field flux? If you want to know the reason, watch our video, Effect of Unity Power Factor Load on Armature Reaction. Now, the induced EMF EPH will circulate current through armature conductors and the sump motor. This current is called armature current, IAPH. Since the sump motor has inductive nature, the armature current will lag the induced EMF. If we consider that it is a purely inductive load, the lag angle between the induced EMF and the armature current will be 90 degrees. This armature current will set up the armature flux phi A. We know that the flux is directly proportional to the current. Hence, we can draw a line parallel to IAPH to represent the armature flux. From the phasor diagram, it is evident that there is a phase difference of 180 degrees between the main field flux and the armature flux. It means, if the main field flux phi F is in the positive direction, then the armature flux phi A will be in the negative direction. Let us plot these fluxes in the XY plane. Both the fluxes will cross the x-axis at 0, 180, and 360 degrees. Let us consider the two poles of the alternator in the XY plane. At both sides of the poles, the armature flux and main field flux are exactly in opposite direction to each other. Hence, the armature flux will try to cancel the main field flux. As a result, the magnitude of the main field flux will get reduced. This reduction in the magnitude of the main field flux is called the demagnetizing effect of the armature reaction. Since the main field flux is the cause for producing the induced EMF, this demagnetizing effect will drop the terminal voltage of the alternator. We hope that you have understood the effect of armature reaction in an alternator when it operates under lagging power factor load. We have come to the end of this video. In this video, we learned that if the load connected to the alternator is purely inductive, the lag angle between the induced EMF and the armature current will be 90 degrees. If the load connected to the alternator is purely inductive, the armature flux will lag the main field flux by 180 degrees. The effect of armature reaction under lagging power factor load is demagnetizing effect. Watch our next video to understand the effect of leading power factor load on armature reaction.